Hi everyone. Today I want to discuss about the solution chapter continuation questions. Now in the previous video I taught up to 15 questions. Now today I want to discuss from the 16th question. The question is an aqueous solution containing 1 gram of urea boils at 100.25 degrees Celsius. The aqueous solution containing 3 gram of glucose in the same volume will boil at. So keep in mind formula for this. Delta TB is equal to I into Kb into molality. When volume same in their mass also same because density will be remain same. So to find out that molality N by W1 in kg, when moles are same, mass is denominator same is there for solvent. Therefore, now we have to find out the moles. When moles are same in their boiling point also same. So now I am finding the moles of urea, that is equal to mass by molar mass. Therefore, mass 1 gram they given and molar mass we know 60 gram per mole. Then gram cancel. Therefore, this is 1 by 60 mole inverse current to mole. Then number of moles of glucose, that is how much here, 3 gram divided by 180 gram per mole. Therefore, this is 1 by 60 mole because 3, 6, 18, 60, this is gram per mole. So, moles are same is therefore the boiling point will be, this is 100.25 mean glucose solution also boils at the same temperature, that is called 100.25 degree Celsius. Next question. Pure benzene freezes at 5.45 degrees Celsius at certain places, but a 0.374 m solution of tetrachloroethane in benzene freezes at 3.55 degrees Celsius. The Kf for benzene is. So how to calculate this? We know that freezing point delta Tf is equal to I into Kf into molality. Then pure benzene freezes, it means solvent this is, and some tetrachloroethane, organic solvent I value, organic compound general I value, which is not undergo dissociation association for that one. So here freezing point tetrachloroethane, molality given, this is a 1, Kf value we have to find out, molality given as a 0.374 molality, and this is a pure solvent that is called 5.45 degrees Celsius, and solution is freezes at minus, sorry, it means delta Tf is equal to T naught F minus Tf. So this is how much pure solvent, 5.45. Now minus this minus symbol here and 3.55 degree Celsius. Then Kf is equal to 5.45 minus 3.55 divided by 0.374. If you cancel 8, subtract and divide it, you will get the 5.08 Kelvin kg mole inverse. But if you try to remember also, direct you can answer from that NCERT textbook, the table given. But in case not remember, you can solve this problem like this. Next one question is 18th. An aqueous solution freezes at this temperature, and this is a Kf value, Kb value. What is the elevation in boiling point? So elevation in boiling point delta Tb is equal to Kb into molality, and delta Tf is equal to Kf into molality. I value here same, whatever the aqueous solution, not mention that word, that's why this is cancel, and molality will be same, therefore it is cancel. Then we have to find out the elevation in boiling point. Delta Tb is equal to freezing point of the solution. So we know that delta Tf is equal to T naught F minus Tf. This is 0 minus 0.186, minus into minus a plus, therefore 0.186. This is a difference of delta Tf, 0.186 degrees Celsius or Kelvin will be same. that equal to Kb value given, that is 0.512 divided by 1.86. Now keep in mind 1 point shifted to here 1.86, then 1.86, 1.86 cancel. Then here what is that, 10 power minus 1, this will be cross multiplied delta Tf or Tb. So delta Tb is equal to 0.512 into 10, that equal to 0.0512. Which answer is there? That is the fourth option. Next, 19th question. Molar depression constant of water is 1.86 Kelvin kg mole inverse. 0.02 mole of urea dissolved in 100 gram of water will produce a depression in freezing point of. So we can solve this question. Then what you have to find out? Freezing point of the solution. Then how to find out this is molar depression constant given and 0.02 mole of urea given. So delta Tf is equal to I into Kf into molality. Then this is 0 minus Tf, because freezing point of the pure water is 0, and degree Celsius, that is I value, which one, urea, therefore 1. Kf value given in the question 1.86. Molality W2, it means that moles only given, so molality is equal to moles by W1 in kg. Then 0.02 mole, then here 100 gram mentioned, therefore W1 is equal to 100 gram, that equal to 0.1 kg. Then I can write here 0.1 kg. Then this, after cancellation, we will get here 1.86 into this 1.1 cancel, then 0.2. So this is nearly double value meaning you will get option fourth one. 1.86, 1.5 only, nearly 3. 1.8 means more than 3, that is called fourth option. So you can calculate, you can multiply and calculate. The next one, what would be the freezing point of aqueous solution containing 18 gram of glucose in 1000 gram of water? Then freezing point formula, we know that delta Tf is equal to I into Kf into molality. Then I value for glucose is 1 and Kf value 1.86. Then molality is mass by molar mass, 180 into 1000 by 1000 gram. Cancel, this is cancel, then here 10. Then this answer is, when 1.86 divided with the 10 means 0.186, that is delta Tf. Then we know that T naught F minus Tf is equal to 0.186. Then this value 0 minus Tf is equal to 0.186. Therefore Tf is equal to minus 0.186. That option is first option. Next question. If 0.1 molarity solution of glucose, 0.1 m urea solution are placed in two sides of the semi-permeable membrane to equal height, then it will be correct to say that, then we have, this is called one beaker, here this is called semi-permeable membrane. Then here 0.1 m urea, 0.1 m glucose. Then both are same concentration, therefore there is no net movement of solvent molecule, then that is called isotonic solution. Isotonic mean what is that? That we have to read the options. In this, there will be no net movement across the membrane. So first option only correct is there, therefore first option. Then next one, 22. If mole fraction of the solvent in solution decreases, then what will happen now? Consider. This is only solvent. Then what happened here? These are all solvent molecule. Next, when you add solute, then we have this solvent plus solute, solvent plus solute, solvent plus solute. Then here this is called solution. Solution meaning what is it? Solvent plus solute. Now read the question. If mole fraction of solvent in the solution decreases. Now what happened here? Solvent molecules are less. Then what happened? These are vaporized. Only solvent molecule will vaporize, not solute, because non-volatile solute added. Then what happened here? Vapor pressure decreases. So vapor pressure decreases, meaning what happened here? Actually more number of solute added, mean boiling point what happened? Increase. And freezing point what happened? Decreases. Next, osmotic pressure what happened? Increases. So according to this one, we have to read the four option. First option, vapor pressure of the solution increase. No, decreases is there. Boiling point decreases, but here increase is there. Osmotic pressure increases, just increase. Therefore, which option is correct? Third option is correct. Next one, 23. The osmotic pressure of solution increases if. Now only we discuss osmotic pressure increases when number of solute particles are increased and solvent particle decrease. Solute particle increase, solvent particle decrease. So we have to read here option temperature is lower, volume is increased, number of solute molecule increase. Therefore, which option correct? Third option is correct. Next one. The density of 2 molar sucrose solution 1.4 gram per milliliter at 25 degrees Celsius. Find the osmotic pressure. Then osmotic pressure formula pi is equal to I into M, that is CRT. Then which one solution here? Glucose or sucrose. So osmotic I factor is 1. Then 2 molal they given, but molality they given, that is 2. Then we have to use which one? Molarity. Therefore we have to write here molarity how much. So we have the relation between molality and molarity, but it takes time. But we know that molarity, what do you call? Molarity is smaller than the molality when water density is equal to 1 gram per milliliter. So how much less? Little less we have to consider. Here 2m given, you can get 1.7 or 1.8 or 1.6 also consider, no problem. So now molarity little lesser than the molality. That value I am using here 1.7 molarity, and R value is 0.0821 liter atmosphere Kelvin inverse and mole inverse. Unit you have to put, then you will get the correct option. Then here 1 by 12, this value is how much? 1 by 12. Temperature how much mentioned? 25 means 298 Kelvin. So now this 1.7 into 1 by 12 into round of I am doing this is 300. Then 3 4s are 12. Then 4 25s are 100. Then 1.7 into 25. 25 double 50, but 1.7 is there, little less is there. So in option which is little less is there, that is a 40.7. Therefore third option is correct. Next, 25. What is the 25th question? Equal volume of 0.1 m urea, 0.1 glucose are mixed. The mixture will have. So now we have 0.1 urea, 0.1 m glucose. Then already now only we discussed they have the same osmotic pressure, that is called isotonic. So same osmotic pressure, that is pi. Therefore which option is there? Second option. Next one, 26th. A solution containing 8.6 gram of urea in 1 liter was found to be isotonic with the 0.5 weight by volume solution and organic non-volatile solute. The molecular weight of organic solute is. So now I am taking here isotonic. Isotonic meaning what is that? Osmotic pressure of first one is equal to osmotic pressure of second one. For this formula is I1 C1 RT is equal to I2 C2 RT. These are same cancel. Therefore I1 C1 is equal to I2 and C2. Then first one is urea, therefore Vanta factor 1, and its concentration is not given, therefore mass by molar mass, that is a moles. Then urea 60 gram and 1 liter means this here 1 liter, because we know the concentration is equal to N by V. This is called N, this is volume, that equal to I. Isotonic organic solvent, then this is also 1. And then concentration, how much given? 0.5 gram weight, and this molar mass we have to find out M2, and its percentage given meaning 100 ml. So 100 ml is equal to 0.1 liter, therefore 0.1 liter. So after solving this, you will get here M2 is equal to 0.5 by 0.1, and next multiply 60 by 8.6. Then this point cancel, and 5 into 6 300, because numerator 300, 35 into 6 30 plus 1 0 300, 8.6. Then what is the answer? Near answer is 34 point something is there. Which option that is the second option? Now the question is Vanta factor I for dilute aqueous solution of glucose. So we know that for which are not dissociate and associate, further Vanta factor is equal to 1 for glucose and sucrose, urea, like this, some organic compounds also. So option what is the second? Now osmotic pressure of 0.585% W by V NaCl solution at 27 degrees Celsius is. So how to calculate this one? Osmotic pressure is equal to I into CRT. Then I value how much? 2, because NaCl Vanta factor 2. Concentration how much? 0.585 divided by 58.5. Mass by molar mass. N mean what is mass by molar mass, and by 1 by V in volume. So this is moles, and now molarity means this is mass by molar mass into 1 by V in liter. Then percentage they given meaning here 100 milliliter. 100 milliliter equal to 0.1 liter. Therefore 0.1 liter. This is into R. R value 1 by 12 in the previous question we solved, and temperature 300 they mentioned here. So now point shifted to here, then 58.5 and into 10 power minus 2. These two zeros cancel for 10 power minus 2, because when you point shift here 10 power minus 2, therefore these two zero cancel. 58.5 cancel. Then 3 4s are 12. Then what we have here, 2 1s are 2 2s are. Therefore pi is equal to numerator nothing is there. Therefore we can say 1, and this is 0.1, and here 2, therefore it is 0.2. Then when it is shifted, then it is 10 by 2 we can write, therefore 5 near answer which is there 4.92 atmosphere, second option correct. Next 29th question. 29th question is the substance A, when dissolved in solvent B, shows the molecular mass corresponding to A3. The Vanta factor is. So we have A is converted into A3. This is 3 moles. Therefore, 3 convert into A3 means this is trimerized. What is this? Is trimerized. Then what is the Vanta factor? Vanta factor I is equal to 1 for glucose and sucrose, like this. I is equal to greater than 1 for dissociation. I is less than 1 for association. So now which is associated form is there? I equal to 1 by 3 is associated form, therefore fourth option is correct. Next, what is the question now? The question is the lowering vapor pressure of 0.1 aqueous solution of NaCl, copper sulfate, K2SO4 are equal. So now we have here 0.1 m NaCl, 0.1 m copper sulfate, 0.1 m K2SO4. Concentration same are there, mean lowering vapor pressure depends upon which one? I value. I value for this 2, I value for this also 2, I value for this is 2 potassium, 1 sulfate mean 3. Here 1 copper, 1 sulfate mean 2, 1 Na, 1 Cl, therefore 2. So like these options are not there, mean we can say 2 1s are 2 1s are 2 1.5s are, therefore 1 is 2 1 is 2 1.5, like this second option is there. Next, the question is phenol associate in the benzene as this equation in if degree of association of phenol is 40%, Vanta factor I is. Association meaning what is the Vanta factor less than 1. So less than 1 is we have two options are there. One is 0.8, another is 0.6. Then which is correct we will select now. Then how to solve this one? Alpha is equal to 1 minus I and 1 minus 1 by n. This is for association. Then this value given 40% mean 0.4 is equal to 1 minus I by 1 minus 1 by n. N value according to this dimerization n equal to 2. Therefore 2. Then this can be written as 0.4 is equal to 1 minus I into 2, because it's multiply here 1 into 2, 2, 2 minus 1, 1, and this denominator 2 goes numerator, 2 1s are 2.2s are. Therefore, we have 0.2 is equal to 1 minus I. I is equal to 1 minus 0.2, that equal to 0.8. Therefore, which option correct? Second option correct. Then next question is a 5.8 W by V percent NaCl solution will exceed an osmotic pressure closest to which one of the following? Then we have to check here. We know the formula in the previous question we discussed. I1C1 is equal to I2C2. Then for this NaCl Vanta factor 2, concentration 5.8 is a mass by molar mass 58.5, volume is percent given, therefore 0.1 liter. Then I2 osmotic pressure of which one? This is option we have to select. For example, I am selecting the option which one now? First option, sucrose mean Vanta factor 1, 5.8 by its molar mass 342 and percent is therefore 0.1. Now observe, numerator is 2 is there, here 1 is there, here 58.5 is there, here this is there, here these are same is there, anyway not equal. Therefore we have to check the another option, 2 into same left side will be same, not change because it is from the question. 58.5 into 0.1, that equal to second option, what is the glucose Vanta factor 1, and this is 5.8 by 180 into 0.1. So this is also not equal. Therefore we have to check another option, 2 into 5.8 by 58.5 into 0.1. Left side will be same. Then here concentration only given. Then I value for sucrose is 1 and concentration 2 given. Then this point will be shifted here, mean 58, then this is also 58, cancel 0.1 cancel, then 2 same is there, therefore these are equal. Therefore which option can be? Third option is correct. The next one, 33 question, which one of the following pair of solution will be expected to be isotonic under the same temperature? So isotonic mean again same formula, I1C1 is equal to I2C2. Then find out urea value 1 first option and concentration 0.1 is equal to for NaCl 2 Vanta factor and concentration 0.1. Both are not equal, so first option wrong. Second option we are checking. Then urea Vanta factor 1.1 m concentration is equal to MgCl to Vanta factor Mg1 Cl to 3 and 0.2. Then these are also not equal, therefore third option we have to check. Then NaCl Vanta factor 2.1 concentration, and this is Na2SO4, this is a 3 and this is called 0.1. So these are also not same. Their automatically fourth option will be equal, but we'll check here. Calcium nitrate quantum factor 3 into 0.1 is equal to, and Na2SO4 3 into 0.1, both are equal, therefore this option is correct. Fourth option is correct. The next one is 34. Which of the following 0.1 m aqueous solution will have the lowest to freezing point? Lowest to freezing point meaning more solute particle required, because already we studied here solvent particle, solute particle, solvent particle, solute particle, solvent particle. Therefore more solute particle, less vapor pressure. Vapor pressure will be decreased and boiling point will be increased. So now the question, what is the lowest to freezing point? So when vapor pressure decreases, meaning a freezing point lowering also decrease. Then vapor pressure increase, meaning a freezing point what happened? Increase. Then we have to think about which one now? More solvent molecule, more vapor pressure. Sorry, lowest freezing point. So we don't want higher freezing point. We want lowest, mean more number of solute required. Solute particle increase, meaning a vapor pressure decrease. Vapor pressure decrease mean boiling point increase, freezing point decrease. So which has a more number of solute particle? Potassium sulfate mean K2SO4. Then I value how much for this? 3. Sodium chloride, I value how much? 2. Urea how much? 1. Glucose how much? 1. So more number of solute particle, first option. Next one, 35. In 35 question, which solution will have least vapor pressure? Least vapor pressure means now only discuss this one. This will be have less solvent, more solute. So solvent particle decreases, solute particle increase mean that has a more less vapor pressure, because less solvent molecule vaporize. So vapor pressure what happen? Decrease. When solute particle increase. So first one, concentration same is there, mean barium chloride, how many particles? Barium 1 and this chlorine 2, 3 particle. Urea 1 particle. Na2SO4 3 particle. Na3PO4 4 particle. Therefore fourth option is correct. Next, 36. According to this, freezing point of 1% W by W aqueous solution of calcium nitrate will be. Now only discuss this one. When this one solvent particle, solute particle, solvent, solute, solvent, solute. When solute particle increases, pure solvent mean what is that? All are solvent, 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 solvent. Therefore freezing point how much? 0 degree Celsius. When solute particle added, then what happens? Its freezing point decreases. So less than 0, less than 0 which is there, below 4 is there, that is option. Next one, 37. Which of the following solution will have highest to boiling point? Highest to boiling point meaning what is that? Solute particle increase mean vapor pressure, decrease mean boiling point increase. So solute particle increase when I factor increase. So all are same percentage mean I value should be greater. Glucose value how much here? 1, I factor. So I value is 1. NaCl how much? 2. Calcium phosphate meaning how much? 3 plus 2, 5. Urea 1. Therefore answer which one? Third option is correct. I value increase mean boiling point increase. 38 question. In when mercuric iodide is added to an aqueous solution of potassium iodide, so what will be happen? So according to this one, mercuric iodide Hgi2 plus potassium iodide, these two combine to form K2Hgi4, this complex form. This is called Nessler's reagent. 2 potassium 2, 2 iodine, 2 iodine, 4 balanced equation. So if it is ionized, Van 't Hoff factor is for this 3, and for this 2 and this 2, 2 into 2, this is a 4 particle. Then 3 plus 4, that is 7 particle. Here how much its Van 't Hoff factor? That is 2 plus 1 square bracket 1, therefore 3. 7 particle to 3 particle. So number of particle what happened? Decreases. So number of particle decreases meaning already I told the number of particle increases mean, in case number of particle increase mean free vapor pressure what happened? Decrease. And boiling point what happened? Increase. Freezing point what happened? Decrease. Osmotic pressure what happened? Increase. But here number of particle decrease means all are reverse. All are reverse means boiling point will be decrease, freezing point will be increase, osmotic pressure will be decrease. So according to this one option, the boiling point does not change. No. Freezing point is raised. Yes, freezing point is raised. So which option correct? Second option is correct. Next, 39th question. What would be the osmotic pressure of 0.1 m K2SO4 solution 90% dissociated at 27 degrees Celsius? So now osmotic pressure means pi is equal to ICRT. Then answer is I value for this K2SO4, but 90% will not 100%. Therefore, I value you have to calculate. Then alpha is equal to I minus 1 by n minus 1. Alpha is 90% 0.9. I value don't know 1. I minus 1. N value K2SO4 3. If it is 100% ionized, then 1. Then how much this is? This 2 and 3 minus 1 2, then 0.8 and 0.9 into 2 1.8, 9 2s are 18. Therefore point is a 1.8 is equal to I minus 1. I is equal to, when 1 comes left side, that is 1 plus 1.8, that is 2.8. Therefore 2.8 concentration is 0.1 and R value 1 by 12, and this is a 300. Then 3 4 is a 4, 25 is a 100, and this point, what is there here? 2.8 into 0.1 into 25. Okay, then it is round up considered nearly 3. 3 into 25 how much? Nearly 75. Rough value, not 100%. Point is there, therefore point I place it because 0.1 is there. So near 7 value which is there, that is the answer, that is the first option. If you do exact, then you will get exact value because I round off, this is 2.83 considered. So less than 7 point, that is 6 value. So here first option. Next, 48th question. Which one has the same Venta factor I as that of the Hg2Cl2? This is the most important because student will consider here Hg2Cl2, meaning they may consider here 2Hg and plus 2 and 2Cl minus, means total 4 particle. That is wrong because we are writing the formula according to crisscross method. Therefore, this is called Hg. Hg, this 2 will be here plus 2, and this is Cl minus form only, but 2 are there, therefore 2, and this 2 will be as it is. Total number of particles are 3 only, so 3 like this. Which option is the second option is correct. But if you confuse like this, Hg 2Cl2, meaning this 2 here, this 2 here, meaning Cl cannot be minus 2, therefore wrong option. So which is correct? This is the correct one. So I hope all questions are completed up to 40 I discussed here. If you have any doubts, you can comment and share to your friends. These are useful for the CET level or NEET level, but actual questions are NEET level question, but it is both purpose, it is useful. And one more thing, if you want any other chapter, you comment it, I will answer all the level 1 level 2 questions. Thank you.